Okay, multiplication principle or rule. If an operation can be carried out in R ways and another operation in S ways, then the number of ways to carry out both is R times S. Let's see an example. Okay, there are 3 different roads to travel from town P to town Q and 4 different roads to travel from town Q to town R. Calculate the number of ways a person can travel from P to R via town Q. Okay, let's see the solution. Okay, let's say we start from town P. Okay, town P to Q, we have 3 different routes. Okay, let's say this is the first route, followed by the second route and the third one. Okay, to reach town Q. Okay, then from Q to R, we have 4 roads. Okay, first road, second road, third road, and the fourth one. Okay, to reach R. Okay, using multiplication rule, you can find the number of ways a person can travel from town P to town R via town Q. Okay, so here you just multiply. Okay, to travel from P to Q, we have 3 routes, and then times with Q to R 4 routes. So altogether you have 12 ways to travel from P to R. Let's see another example. A man has 4 pairs of pants, 6 shirts, 8 pairs of socks, and 3 pairs of shoes. In how many ways can he get dressed? Okay, so again we are going to use multiplication rule. Okay, so since he have 4 pants, so 4 times 6 shirts times 8 pairs of socks and 3 pairs of shoes. So altogether, okay, he have 576 ways to dress up. Okay, now let's see what is permutations, and before that let's see what is n with the symbol exclamation. Okay, so n exclamation is read as n factorial. Okay, so what is how do we find n factorial? Now see, let's say you have n factorial, so it is equals to, first start with n, then you reduce 1 each time. So n minus 1 followed by n minus 2, n minus 3, and so on until you reach 3 times 2 times 1. Okay, for example, let's say you have 4 factorial, then 4 times 3 times 2 times 1. Okay, same thing, if you have 6 factorial, then it is 6 times 5 times 4 times 3 times 2 and times 1. Okay, multiply all this, then you will be able to get the value of 6 factorial. Okay, and remember, okay, 0 factorial equals to, okay, example 2, calculate the following. Okay, the first one, 7 factorial. So if you remember, 7 factorial equals to 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, final answer is 5040. Okay, next, let's say you are given to you are asked to simplify 7 factorial over 5 factorial. Then you can write this as 7 factorial. Now see, I am going to expand only until 5 factorial. So 7 times 6 and then I stop at 5 factorial. Divide 5 factorial. So 5 factorial can be cancelled and your final answer will be 7 times 6 equals to 42. Next, let's say you have n factorial over n minus 2 factorial. So now n factorial, I'm not going to expand all, so n times n minus 1 times n minus 2 factorial, I stop here, over n minus 2 factorial. So n minus 2 factorial and n minus 2 factorial can be cancelled, and the final answer will be n in bracket n minus 1. Okay, n factorial can also be calculated using a scientific calculator. So for example, to calculate 7 factorial, okay, so if you have your calculator with you, you press 7 and then press shift and then you press the symbol exclamation. Then you will be able to find the answer, that is 5040. Permutations of n different objects. Okay, now remember, permutations mean arrangement. Okay, you are asked to arrange the objects. Okay, the number of permutation or number of arrangements of n different objects can be obtained by using the first method will be n factorial followed by npn. Okay, npn, you can calculate this by using calculator. So if you look at your calculator, at the key multiply on top there, you can see the NPR. Okay, so later I'll explain how to use the NPR symbol. Okay, the third one is box method. Okay, now let's look at an example. Find the number of arrangements of the letter A, B, and C. Now you are given 3 letters A, B, and C. Now find the number of arrangements. Okay, how many ways we can arrange these 3 letters? So the first arrangement can be A, B, C. So this is the first arrangement. Okay, the second arrangement can be written as A, C, B. Okay, or B, A, C, or B, C, A, or C, A, B, and C, B, A. Okay, can you think of any other arrangement? I don't think so, because we have only 6 arrangements for these 3 letters. So the total number of arrangements equals to 6. Now, you can also find the total number of arrangements by using the factorial. Since we are given 3 letters, we are going to arrange all 3. Remember, we are going to arrange all 3. Therefore, it is 3 factorial. So we just learned how to find the value of 3 factorial. So it is 3 times 2 times 1 equals to 6. Or you may also use calculator to find the value. Or you may also use the second method, that is NPN. Okay, so here you are given 3 letters. So 3P3. Given 3, arrange all 3. So it is 3P3. P here means permutation. Okay, 3 objects given, arrange all 3. So 3P3 equals to 6. Now you can take out your calculator and see where NPR is. Okay, so first you press the number 3 and then shift key multiply. Okay, then you can see the P there, and then times key in the 3 again, then equals to. So you will be able to get the value 6. Okay, if you do not understand, maybe in later slide I can explain again. Okay, now next, using the box method. Okay, now how the box method works? Okay, now for the first box, okay, you have three options. Okay, you have letter A, B and C. So since we have three options, so you put the value 3. Let's say one of the letter is already taken by the first box. Then for the second box, we have remaining another 2 letters only. Okay, so therefore you put there 2. That means now we have already occupied the first box, occupied the second box. That means we have already taken out 2 letters. So at the end we have only one more left. So for the third box, the options we have is only 1. So you multiply all this and you will be able to get the answer. So these are the 3 ways to find the arrangement of n different objects. Remember, here given n object, you arrange all n objects. Example 4. In how many different ways can we arrange 5 books in a shelf? Okay, again I'm going to explain all the 3 methods. Okay, you just choose one to find the answer. Okay, the first one using the factorial. So number of different ways, since we have 5 books and we want to arrange all 5. So the number of arrangement that we can get will be 5 factorial. Okay, use your calculator and you will be able to get the answer as 120. Or by using NPN. That means now we have n books. We are going to arrange all the n books. So now here we have 5 books, arrange all 5. So it can be written as 5p5. So take your calculator, press the number 5. Okay, then press shift and then the symbol multiply. Okay, you will get the symbol p there at the display. Okay, now again press 5. Therefore we have 5p5. Then equals to, you will be able to get the answer as 120. The third method will be the box method. Since we have 5 books to arrange, so you prepare 5 boxes. Okay, now for the first box, here we don't have any other condition to follow. So we just randomly just choose one to put in the first book. But then now for the first box, we have 5 books. That means 5 options. So the number of options for the first box will be 5. Now let's say we have already chosen one out of 5. So for the second slot, we have only 4 books remaining. So it is 4. Now taken out one more. Then you have only 3 books to choose from. Okay. Then you reduce one more. Then you get 2. And the final answer, you multiply all these numbers. And it is equals to 120. So these are the 3 ways which you can use to calculate the number of ways to arrange n different objects. Now we have already seen permutation of n different objects. Now let's that is NPN. Okay, just now we just learned. Okay, now let's see permutation of n different objects taken R at a time. So before this we have n object, we arrange all n, but now we have n objects, but then we only take R to arrange. Okay, so for example, let's say we have 5, we only choose 3 to arrange. Okay, a permutation of n different objects taken R at a time is an arrangement of a set of R objects chosen from n objects. the order of the objects is the chosen set is taken into consideration. The number of permutations of n different objects taken r at a time is given by, okay, so this is the formula. Now remember, if you go back to the previous lesson just now, permutation of n different objects, the formula is npn. You have n, you arrange all n. Now you have n, but you only arrange r at a time. Okay, so it can be written as npr equals to n factorial over n minus r in bracket factorial. So please remember this formula. Okay. Okay, now before we go into the problem solving, let's see how to apply this formula. Okay, now NPR. Okay, even though you can use calculator, you still need to know this formula. So NPR equals to n factorial over n minus r factorial. Okay, so for example, let's say now you're asked to calculate the value of 7P2. Okay, 7P2. So now 7P2 can be written as 7 factorial over 7 minus 2 factorial. Okay, so 7 minus 2 factorial equals to 5 factorial. So 7 factorial over 5 factorial equals to, okay, expand the 7 factorial. So 7 factorial can be written as 7 times 6 times 5 factorial. You stop there. Okay, over 5 factorial. So 5 factorial can be cancelled. So the final answer is 42. Okay, example 6, evaluate 5P2. Okay, so 5P2, remember the formula NPR equals to n factorial over n minus r factorial. So here 5P2 equals to 5 factorial over 5 minus 2 factorial. Okay, simplify 5 minus 2, so it is 3 factorial. Okay, so expand the 5 factorial as 5 times 4 times 3 factorial, stop there, over 3 factorial. So 3 factorial and 3 factorial can be cancelled. So final answer is 5 times 4 equals to 20. Okay, so as I said just now, NPR, the value of NPR also can be calculated using a scientific calculator. So for example, if you want the value of 7P3, press the following keys. Okay, 7 and then press Shift NPR. Okay, NPR is above the operation multiply. Okay, and then press 3 equals 2. So your answer will be 210. Example 7. 5 letters from the word Kurlipan will be arranged in a row. Calculate the number of possible arrangements. You are given the word Kurlipan. So altogether we have 8 letters in the word Kurlipan. Okay. From the 8 letters, you are asked to arrange 5 letters. So let's see the solution. I'm going to use the box method. Okay, now box method is very useful. So make sure you know how to use the box method. Now for this case, for this question, we don't have any condition given, extra condition not given. You are just given 8 letters, you choose 5 to arrange. So now using the box method, in order to fill the digit in the first box, okay, now see, we have altogether 8 letters to put in the first box. We have 8 options. Okay, So we write digit 8 in the first box. We have 8 options, so that means the first box is filled with the digit 8. Now for the second box, let's say we have already filled one letter for the first box. Okay, that means remaining we have only 7. Okay, now see, let's say letter K already occupied the first box. That means we have another 7 letters only left. Now remember, for the first box, again go back to the first box, we have altogether 8 options. I can put letter K in the first box, or letter E in the first box, or letter R in the first box, and so on until I finish all the letters. So altogether I have 8 options. Let's say one letter already occupied the first box. That means remaining for the second box is only 7. And do the same thing for the third box. For the third box, let's say one more letter is already occupied. That means altogether we have used 2 letters. It can be KE, KR, RL, and so on. But then we have already used 2 letters. So for the third box, we have only 6 letters remaining. And for the fourth box, we have 5. And for the fifth box, we have only 4. Okay, so this is box method. Now multiply all these digits and you will be able to find the number of possible arrangements. So altogether we have 6,720 arrangements that we can make from the word Kerlipan by just choosing 5 letters from it. Okay, now another way of solving rather than using the box method. Okay, so you are given 8 letters, arrange 5. Given 8, choose 5 to arrange. So 8p5, so equals to 6,720. This one you can use calculator to calculate the value. Okay, since we don't have any other condition, given 8 letter, arrange 5, so you can straight away use the formula 8p5. Okay, example 8. How many 4 letters codes can be formed using the letters in the word gracious without repetition such that the first letter is a vowel? Okay, now let's look at the solution. Now here we have condition to follow. We are going to form 4-letter code from the word gracious, but the condition here is the first letter have to be a vowel. Okay, now that means for the first box we have 4 options. We can put in the letter A, I, O, or U. Okay, from the word gracious we have A, I, O, and U to be fulfilled in the first box. Why? Because the given condition, okay, the first letter have to be a vowel. Okay, so we have 4 options for the first box. Now for this case you have condition to follow, so therefore we have only 4 options for the first box. You cannot put in the total as total letters in gracious. You have 8 letters, so you cannot put 8 as the digit in the first box. Okay, it is only 4 which fulfill the given condition. Okay, for the second box we don't have any condition to follow. So let's say from the word gracious we have already taken out 1 vowel. That means remaining we have only 7 to put in the second box. And for the third box you reduce one more, therefore you have only 6, and then for the fourth box you have 5, because we have already chosen 3 letters. Okay, so left only 5 letters to put in the fourth box. Okay, so now see, this is how the box method works. Okay, when you have, especially when you have condition to follow. So for this case, the first letter have to be a vowel. So we have only 4 options here. Okay, that is why we fulfill the first box with the condition, then you reduce the letters 1 each time. Okay, so now you multiply the digits. 4 times 7 times 6 times 5, so equals to 840. Okay, so that will be the number of arrangement. So for this case, you cannot straight away take 8P4 to form the code, and you will get the wrong answer, because for this case you have condition to fulfill. So using box method will be very useful. Example 9. The diagram below shows 5 cards of different letters R, E, A, C, T. Okay, now first calculate the number of arrangements in a row of all the cards. So first case, we want to arrange all the cards. Okay, that means you have 5 letters, arrange all 5. So do you still remember how to arrange all 5? Okay, so let's look at the solution. So number of arrangement, just 5 factorial equals to 120. Or you may use NPN, that means 5 in order to find the answer. You will get the same thing, that is 120. Okay, now let's look at B. Calculate the number of this arrangement in which the letter E and A are side by side. Okay, now for question B, you have condition to follow. We are going to arrange all the 5 letters, but then the condition now is letter E and A have to be side by side. They have to stick together. Okay, first thing, let's see got how many arrangement you can make in order to make sure that the letter E and A are side by side. Okay, now so this will be, I'm going to use the box method. Okay, as I said before, box method is very useful, very helpful. Okay, so you can put the letter A and E. Okay, so this is the position of A and E. It can be arranged in this way, or it can be arranged in the second way. Okay, now see the position of the letter A and E, or you can arrange as this, or like this. Okay, anymore? Okay, I don't think so. So these are the arrangements or the ways you can arrange the letter A and E to be together or to be side by side. So altogether you have 4 ways. Okay, so number of ways for the letter E and A to be side by side, altogether got 4 ways. Okay, now this is not the answer yet. Okay, we just found the number of ways to arrange the letter, to position the A and E together. Okay, now see the letter A and E itself, you can arrange it as AE or EA, AE or EA. Therefore, we have 2 ways of arranging the letter A and E, or 2 factorial. You may use 2 factorial. We have 2 letters A and E. Arrange these 2 letters. Therefore, it is 2 factorial. Now look at the green boxes. So the green boxes will be filled by letter R, C and T. And these 3 letters also need to be arranged. So since we have 3 letters, that is they are R, C and T, so it is 3 factorial. The number of ways to arrange the letter R, C and T equals to 3 factorial. Okay, so now we calculate the total arrangement. Okay, therefore it is 4. Why 4? Because number of ways to arrange the letter A and E to be side by side. So 4 ways times 3 factorial. Why 3 factorial? Because we want to arrange the consonant R, C and T, and then times 2 factorial, that is for the letter A and E. Okay, so multiply everything and you will get the total arrangement. Okay, example 10. A group of 4 men and 3 ladies are to be seated in a row for a photographing session. If the men and ladies want to be seated alternately, that means man, lady, and so on, calculate the number of different arrangements. Okay, now, so here we have 4 men, 3 ladies. We want to arrange all of them. Okay, but with condition. So what is the condition? They have to sit alternately. So man, lady, and so on. Okay, let's see this arrangement. So altogether we have 7 seats. So the arrangement have to be man, lady, lady. Sorry, man, lady, man. Okay. Now you cannot arrange it as lady, man, and so on because we have only 3 ladies. So this is the only way to be seated. Okay, so we have only one way of arranging to fulfill the given condition. Okay, now therefore the total arrangement, so number of ways to sit is only 1 times 4 factorial. Why 4 factorial? Because we want to arrange, okay, all the men. So altogether got 4 men. So 4 factorial. And then the ladies, all the ladies, number of ways to arrange the seat for ladies is 3 factorial. Okay, so multiply all and you will get the answer, that is 144. Okay, example 11. Ahmad has 6 durians, 5 watermelons and 2 papayas. If he wants to arrange these fruits in a row and the fruits of the same kind have to be grouped together, calculate the number of different arrangements. Okay, the size of the fruits are different. Okay, now see, we want to arrange these 3 fruits, okay, and they have to be grouped together. So let's see the arrangement. So you can put all D together, followed by all watermelon, and then followed by papaya. Okay, so here now durian, watermelon, papaya. Okay, we can do the arrangement for these 3 fruits. So that will be 3 factorial. You can see, now you are given, for this case, for the first example, the arrangement is durian followed by watermelon followed by papaya. It can be some other arrangement, maybe watermelon first followed by durian and then papaya. Okay, you arrange, since we have 3 fruits, so you arrange all these 3. So number of arrangement can be obtained by finding answer for 3 factorial. Okay, so that is only the arrangement. Now we need to arrange the 6 durians. So 6 durians itself, the arrangement, number of arrangement for 6 durians will be 6 factorial. Same thing for watermelon. We have 5 watermelons, so the arrangement, number of arrangement for these 5 watermelon, watermelon 1, watermelon 2, watermelon 3, watermelon 4, watermelon 5. So total number of arrangement for these 5 watermelons will be 5 factorial, followed by the arrangement for 2 papayas, so 2 factorial. So multiply all this and you will obtain the answer, that is 1,036,800. Example 11. How many 4-digit even numbers can be formed using the digits 1, 2, 3, 4 and 5 without repetition? Okay, that means you cannot repeat the digits. Okay, now let's see the solution. Okay, first you need to prepare the empty boxes. Since we want to form 4-digit number, therefore you prepare 4 empty boxes. Okay, now you need to check the condition. So here we need 4-digit and the number have to be an even number. Now if you still remember, you can easily identify even number by checking the last digit. Therefore, for this case, you need to identify the digits that can be fulfilled in the last box. Okay, so if you check the given digits 1, 2, 3, 4 and 5, 2 and 4 are the digits that can be used in the last box. Okay, that means we have two options here, that is digit 2 and digit 4. So we have two options. So the last box can be filled with the value 2. Okay, now we don't have any other condition. Therefore, you can go back to the first box. Okay, for the first box, okay, we have 5 options. Originally, we have 5 options, but then since we have already occupied the last box, okay, maybe we occupy the last box with digit 2. Therefore, remaining we have only 4 options. Okay, so the first box can be filled with value 4. Okay, why 4? Because we have remaining another 4 options only. Okay, followed by the second box. Okay, for the second box, maybe we have taken out the digit 1, digit 2, for example. Therefore, remaining we have only 3 options. Okay, so put in 3, the value 3. Okay, for the last box, okay, you can guess, remaining we have only 2. Okay, so in order to find the number of ways to form 4-digit even numbers, so calculate all. Okay, 4 times 3 times 2 times 2. Okay, so total we have 48 arrangements.